While writing the electronic configuration of elements, we need to follow three rules. The first one is Aufbau principle. The second one is Pauli's exclusion principle. The third one is Hund's rule. So in today's video, let us solve a question related to the rules for writing the electronic configuration. Hello everyone, I am Srinivas Bisala. You are watching Chemistry is Easy. So let's read the question here. Which of the following electronic configuration violates both the Pauli's exclusion principle as well as the Hund's rule? So before solving this, let me give you a quick recap of all the three rules. Here is the first one, Aufbau principle. What it is? According to this one, electron always enter into the orbital of lowest energy. Electron always enter into the orbital of lowest energy. Means the electrons are filled in the orbitals in the increasing order of their energy. By chance, in any case, if the lower energy orbital is not completely filled, but the electron is entering into higher energy orbital, then we say that that particular element is not following this Aufbau principle. Let's see the second rule, which is the Pauli's exclusion principle. According to this one, no two electrons in an atom can have the same set of all four quantum numbers. No two electrons in an atom can have the same set of all four quantum numbers. In another way, an orbital can accommodate a maximum of two electrons with opposite spins. Means by chance, if there is any orbital where both the electrons are spinning in clockwise direction or in anti-clockwise direction, it means that particular configuration is not according to the Pauli's exclusion principle. Then the third rule, that is the Hund's rule. And according to this rule, whenever degenerate orbitals are available, pairing of electrons takes place only when all the orbitals are filled with one electron each. Let me tell you what is the meaning of degenerate orbitals. The orbitals of the same sublevel with equal energy, they are called as degenerate orbitals. So here, this is the p sublevel with three orbitals and all of them possess the same amount of energy. And that is the reason why we call them as degenerate orbitals. Same with the case of d sublevel, where there are 5 orbitals and the energy of all the 5 orbitals is the same, and we also call them as degenerate orbitals. Then according to this rule, pairing of electrons takes place only when all the orbitals are filled with one electron each. So if there is any case where without one electron in all these orbitals, if pairing takes place, it means it is not according to the Hund's rule. Now let's move to the options here. Let us solve option A. See, in option A, the lower energy orbital is completely filled, then electron entered into higher energy orbital. It means it is according to the Aufbau principle. Then there is no orbital where two electrons are spinning in the same direction. It means even Pauli's rule is followed here. Now let's see the third one, Hund's rule. What is Hund's rule? There should be one electron in all the orbitals, then only pairing should take place, isn't it? But here in this particular orbital, there is no electron, but pairing already took place in these degenerate orbitals. So that is the reason why this particular electronic configuration is not following Hund's rule. So this is wrong according to Hund's rule. Let's move to the next option. Here again lower energy orbital is completely filled. So Aufbau principle is followed. And see here, both the electrons are spinning in the same direction. In an orbital, when both the electrons are spinning in the same direction, it means that is not obeying Pauli's exclusion principle. So Pauli's principle is not followed here. Let's see about the Hund's rule. Then see here, this orbital is vacant, but already pairing took place here. So it means without filling all the orbital with one electron each, and if pairing takes place, it is not obeying Hund's rule. So this particular electronic configuration is not following Pauli's principle as well as Hund's rule, and that is our answer, isn't it? But still, let us solve the remaining two options also. In option C, all the rules are followed because the lower energy orbital is completely filled. There is no orbital with two electrons with the same spin, and pairing took place only when all the orbitals are filled with one electron each. So यहाँ पे all the rules are completely followed. And don't get confused with the downward arrow. The first electron can enter into the orbital with clockwise spin or with anti-clockwise spin. Doesn't matter. Let's see what is happening in option D. In option D, see here, the lower energy orbital is not completely filled, but the electron entered into the higher energy orbital. It means this is not following Aufbau principle. Then see this orbital. Here there are two electrons spinning in the same direction. Means here the Pauli's exclusion principle is not followed. And again see here, there is a vacant orbital here. Pairing of electrons took place here without filling this particular orbital. Means Hund's rule is not followed. So in this particular option, all the three rules are not followed, and in the C option, all the rules are followed. Anyhow, for this particular question, our answer is option B. So let me give you one more question. Here it is. There are two electronic configurations for which you need to tell me the answer. Which of the following rules are not obeyed by the element with a given electronic configuration? I didn't give any options. You need to try what are the rules which are not followed by this electronic configuration as well as this electronic configuration. Please type your answer in the comment box. And if there is anyone who didn't subscribe to the channel yet, please do it immediately. Thank you very much. Meet you again in the next video.